Okay, in this example, we're going to use the intermediate value theorem to prove or show that this polynomial, 3x cubed minus 10x plus 9, has a real zero somewhere on the interval from -3 to -2. Okay, so in between those two numbers, between -3 and -2, there's got to be a real zero for this polynomial. That's what we're going to prove. We don't know it yet, but we're going to prove it. To prove it, all I'm going to do is very simply calculate the function value at each of those endpoints. All right, f of -3 and f of -2. All right, so if I plug in -3, I get 3 times -3 cubed is -27, minus 10 times -3 plus 9. To evaluate that, that'd be what, -60, and it'd be -81, plus 30, plus 9. Well, here the negative definitely outweighs the positive. I don't need to actually find the value, I just need to know the sign of this. This is negative. Okay, very important that it's negative. When I plug in the -2, I get 3 times, be -8, minus 10 times -2, plus 9. Here the double negative makes a positive. This is -24, so it's -24 plus 20 plus 9. And you can see here the positives, 29, outweigh the negatives of 24. And so this answer is going to be positive. Okay. Again, I don't need to actually evaluate them, I just need to know what the sign is, negative and positive. Now, because one is negative and one is positive, that must mean the function goes through 0 somewhere in between. All right? And so that means that by the intermediate value theorem, I'll abbreviate it IVT, there is a number C on that interval such that f of C equals 0. So there's some number C, we'll call it C, that is a 0 of the polynomial. Okay, in other words, f of C is equal to 0. All right, and now that's a guarantee based upon the intermediate value theorem.